I clap my hands. Someone, somewhere, is wrong on the internet. No, I mean, people are wrong all over the place, all walks of life. But wrong on the internet is that really special kind of wrong, where it starts with, today is the 5th of March, and someone replies, actually it's the 4th of March, and then it goes to, yeah, well, I'm going to come into your house in the night and set fire to your bed. I mean, if you want to observe this particular level of escalation, I mean, you really just need to go to any YouTube comment thread. But YouTube comments are like the McDonald's of internet drama. You know, it's quick and easy, it's always going to be there. But the true connoisseur of internet drama knows you want to find those niche forums. That's where the real gems are. I mean, I frequent a knitting forum, and knitters are lovely. You know, they sit around and they talk and they make hats for babies. And then they find out that you are using the wrong yarn to make the hat for the baby. And you are basically Hitler. And usually I just sit back and you know, get the popcorn out and I enjoy it. I don't participate, it's no fun. But sometimes I feel professionally compelled to get involved and maybe correct people who are being wrong on the internet. And my own profession is, I'm actually a quantum physicist. And it may surprise some of you to learn that occasionally people are wrong about quantum physics on the internet. I mean, obviously nobody in this room would ever, not other people are wrong about quantum physics on the internet. But you know, you get things like discussions on quantum teleportation. And it's really, people get really excited because teleportation is like Star Trek, but like 200 years earlier than expected. It's fantastic. But then you're a quantum physicist in a discussion about quantum teleportation, and it's like you're crushing people's dreams one by one. Because let's talk about what is quantum teleportation. So let's start with, you know, I'm a physicist, we'll start with a single atom. And I'm going to teleport this atom behind the bar. So the atom disappears from here, poof, appears behind the bar, poof, teleportation. Not what we mean. So if I actually want to teleport something behind the bar, I have to get together with one of the lovely bar staff beforehand, and we have to share a pair of entangled particles. They have an entangled particle, I have an entangled particle. Then I take the atom that I want to quantum teleport. So I have atom and particle, and I do some science. I'm a theorist, I just do the maths. So I do that, and the entanglement between the particles and this quantum state of the atom ends up on the particle over there. So particle, particle, atom, at the start, particle, particle. Nothing has moved. Everything is where it was. It's just the information that has moved. So it's a bit disappointing. It's not quite beaming up Scotty. But you know, people are so resilient. They really want to see this being okay. So they see the silver line. They're like, it's okay, Suzanne. We can still make this cool. Faster than light communication. Right? Instantaneous entanglement, that bit's instantaneous, yeah? Faster than light communication. You could be anywhere in the world. You could be on Mars, on Pluto, on another galaxy, and you could know without any delay the moment someone was wrong on the internet. It's great. Not how it works. What actually happens is that particle, particle, atom, I do the science part, but the entanglement is instant, but information is not the same thing. So I do the science, and then I have to pick up the phone, which is a regular, less than fast than light phone. I have to be like, yeah, I did the science thing, okay, now you need, no, push the other button, yeah, okay, You're going to set fire to my bed? And, I mean, I don't want to be like Dr. Downer about this, because I want teleportation just as much as you guys do. Because my job involves traveling. I have to travel to conferences, you know, several times a year, which sounds really cool, but it involves an awful lot of airport security, theatre, and hassle to go to a conference that actually might not be that interesting once you get there. And once you get there, there is a way of telling whether a conference is going to be good or not. Look at the food. I've never found a counterexample where it wasn't a case where if the food is good, the science is really interesting and exciting. Wilted lettuce, wilted physicists. By the way, how are the sweets tonight? Because I would be funnier if there were full-size Mars bars. So what I want to be able to just like teleport in, egg salad sandwiches, teleport home. And I know that, like, I'm complaining about this, but compared to, like, a climatologist or an immunologist or Kate, I don't have much to complain about because people are so enthusiastic about quantum physics. They really like it. They want to see what it can produce. They're really enthusiastic. They're just wrong constantly, and I can understand because quantum physics it can come across as quite out there. It's very counterintuitive, so I can understand how if you're not trained in the discipline, it's very hard to tell me, talking about my own research, and some random guy spouting what is actually nonsense. So I'm going to talk a little bit about one of the types of problems that I'm working on at the moment, so that kind of, once you've heard some real quantum physics, you'll be able to distinguish it from some random guy on the internet. So we're going to start small again. I want you all to think of a number. Add 1. Take 1 away. Is that your number? Am I the only, I'm probably not the only one in this room who, when someone says think of a number, goes X. I can see some nodding somewhere there. So you can see the idea. We can generalize it away from just like adding and subtracting. One, if you add something and immediately take it away, it's basically mathematically the same thing. So more abstractly, I am one person on the stage in front of you, and you can think of me one person plus Tom Hiddleston minus Tom Hiddleston. Yeah. Sorry, but that's mathematically equivalent to what you actually see before you. I know he's not really here. It's just maths. Really optimistic maths. But you get the idea. So we'll take this a step further. So I am one whole person, which means I'm 2 half people. So 1 person, 2 half people, that's exactly mathematically equivalent to what you're seeing right here. So now, take it a step further. I am half a person plus half a person, plus half a horse, minus half a horse. Exactly the same as you can see right here, mathematically. I'm going to rearrange that slightly. Half a human, half a horse, plus half a human, minus half a horse. Centaur. Now, so you can generalize this to mermaids, and frogs, and many other mythical creatures. So that's kind of... This seems like an awful lot of hassle and half horses. But, I mean, humans and horses are really easy for us to deal with. But sometimes you want to access the quantum properties of a centaur. That's going to be really useful. So that's why you might want to build a centaur. And the problem is, because like I said, that's exactly equivalent to what you can see right now, but you can't see the centaur. Right? Okay, test. But the reason you can't see the centaur is because you've also got the plus half a human, minus half a horse here. So really the problem boils down to, how do we get rid of half a human and minus half a horse so that we can really take advantage of the centaur? So now that I've told you a bit about my research, I hope that next time you see a discussion of quantum physics online, you will obviously be able to distinguish real quantum physics, like I just told you about, from complete and utter nonsense. So I hope you've all learned something. Thank you for your attention. Just remember, every time you clap, someone is wrong on the internet.